In this video, we're going to be talking about sound energy. So sound is actually a form of energy that is a disturbance within a medium. Because it's a disturbance within a medium, it is not able to travel through a vacuum, only through the three mediums that we know, which is air, solid, and liquids. So sound energy is a type of a longitudinal wave because it has both rarefactions and compressions. So rarefactions is basically where the particles in a wave are spread out, while compressions is where in the wave the particles are basically compressed together. The wavelength is the distance between one entire wave, so from crest to crest or trough to trough. However, in sound waves, what happens is that instead of it being crest to crest and trough to trough, it's actually one rarefaction plus one compression that makes an entire wave. The frequency is the number of waves that happens during a given time. The pitch of a sound would be how high the wavelength would be, and so if it was to have a high pitch, it would have a high wavelength. If it were to have a low pitch, it would have a smaller wavelength. And lastly, we have amplitude, which is the distance between that directional propagation and the crest or trough. So light travels faster than sound. Hence the reason whenever there's a thunderstorm, you would often see the lightning before hearing the thunder. So the thing about sound energy is that since it's a disturbance within a medium, what's happening is I'm going to have six different air particles over here. Let's say this part over here is the source of the sound, and this part is, example, like my ear. If that were to happen, then since the sound is a disturbance, it's going to be causing like a chain reaction. So the disturbance would cause the first particle to hit the second particle, then it would go back to its original position, but the second particle would hit the third particle, and the second part would go back to its original position. This happens all the way until eventually the sixth particle would then hit my ear. Because the sixth particle is hitting my ear, that's how we're able to hear things. And because that sixth particle, it enters into the ear and it vibrates that eardrum, which then activates our auditory ossicles, then our cochlea, and then it travels through our auditory impulse or auditory nerves. Now, the thing about sound is that since it's a disturbance between a medium, what's happening is that it's actually moving much more faster through solids, then it moves faster in liquids, and then lastly, it moves least fastest in gas. Since gas doesn't have that many particles for it to vibrate or for it to disturb, what happens is that it travels slower. But since in a solid, there's more particles and they're much more compact together, the momentum from one particle to the other particle would be much more greater. Hence, it's able to move faster. And since there's more particles, it's able to also vibrate at a higher speed. Hence, solids are able to allow sound to travel faster than liquids, and then lastly gas. So now we're going to be doing a simple demonstration. We're going to be creating sound by these two objects, and we're going to be showing how the sound vibrates and is able to show disturbances with the rice grains over here. We could see from that clip that the rice grains were moving, not exactly a lot, but that shows how the sound energy is formed by rarefactions and compressions. Originally, when this part over here hit this object over here, the sound wave moved, and what happened is that it caused a disturbance within the air, and because it caused a disturbance, the disturbance caused the rice grains to start moving. It didn't exactly move a lot, but it shows how the sound energy moves through rarefactions and compressions. Compressions being where the sound particle is mainly here, and rarefactions as it moves away from the source of sound. You can even see with the slinky here, you can see rarefactions here, compressions here, compressions here. So one rarefaction plus one compression creates a regular wave in a longitudinal wave. And if we were to say this is the source would originally cause a lot of compression, so the sound waves would be much more together, but then as it moves further away from the source, it would enter into a rarefaction state, and then eventually it would just go out. So like it would this. You can see that when it's coming, when I do this, all of it is compressing over here, but then that energy moves and it enters into the rarefaction state. So like the energy is still moving through the wave, but the compression is mainly happening here and here, but there's a rarefaction state in the middle. This is basically how a sound wave is able to move through. If I were to try to draw this regularly, let's use these 6 waves, for example. When it's moving, the particles are either together, like this, or they're far apart, like this. And when we observe this change happening, we could kind of draw a wave like this. So it starts over here with the compression. Then if I were to draw the wave, we would have a rarefaction here, but then another compression over here, but then it would come back down and then go back up, then another compression here, and the cycle would continue on. So this shows how this entire part here, a compression plus a rarefaction makes a single wave. So to summarize, sound waves is basically a disturbance within a medium. So because it's a disturbance within a medium, it's not able to travel through a vacuum. Sound waves are longitudinal because it includes a compressional wave and a rarefaction. And lastly, sound waves are mainly move faster through solids, then liquids, then gas, because solids contain a much more higher amount of particles. Liquids also contain a higher amount of particles, but not that many particles compared to solids. And also solids, since they have more particles, they're able to generate a greater momentum and are also able to move, and also the particles are able to hit each other much more easily, creating that vibration that we know.